Hello everyone, this is Christine G, and I've been having some questions on this problem and wanted to get a video out for everybody. Let's see, here we are conducting a test at the alpha level of 0.05 and we're determining some different things here. So let's go ahead and jump in right away with part A. And it says to choose the correct null and alternative hypotheses below. So the null means that there's no difference between the two, or same way of reasoning that is that the P1 is equal to P2. So right away we can get rid of P1 equals 0. So that doesn't tell us that those two aren't equal. It just tells us P1 is 0, and we don't even know that. So we'd eliminate D, and then the alternative is always what we're testing. So that would be P1 is greater than P2. So right away we'd pick that one, check our answer. That looks good. And then determine the test statistics. So we can easily do this in StatCrunch. And so here is all of my data that I need to use, and it's a sample summary, and you can see x sub 1 is 128. That's the number of successes over the observations, which is n sub 1 of 247. So here I go into StatCrunch, and I'm going to be using proportion statistics, and this is a 2-sample test. And then, oops, I have to move that over some. So proportion statistics, 2-sample test with summary data. Okay, and now I'm going to have to make this smaller. There we go. So now I can put in my data, 128 for the first sample for the number of successes, and then the next one, so number of observations is 247, and then the next sample is 131. That's the number of successes out of 311. Then we're doing this hypothesis test. P1 minus P2 equals 0. That makes sense. If they're both the same and we subtract them, they're going to equal 0. And then the alternative we have over here is P1 is greater than P2. So we got to change that to match up. And then we should go ahead and compute this. And the test statistic, the z-stat, is 2.282. So we put this in here, 2.282. So it says round to 2 decimal places, so we leave it like that. And then the p-value is also in this data summary. So let me see if I can get it out. 0.0112. Okay, and that's to 3 decimal places, and they are picky in this my stat lab, so definitely you want to have the right number of places. Okay, I wanted to talk about this last one. What is the result of this hypothesis test? So let me try and explain what we're doing here so everyone gets a better understanding. So we have this bell-shaped curve. Oops, this is not working. Hold on. Let me try this again. So we have the normal bell-shaped curve, and we are doing a, let's take a look at this. We are doing a right-tailed test because P1 is greater than P2. So this alpha level of 0.05 is going to be on the right tail. So let me try and go ahead and show that. And that's the area. This should be all symmetric and nice and straight and everything, but I'm just illustrating this so it's not drawn too the way it should be. So anyway, down here in this tail is 0.05 or 5% of the data. And that is our rejection area. So if you had something, if we came up with a p-value down in this tail below that, then that would be far away from the null. And here our p-value is 0.011. So our p-value would actually be, and of course I'm not trying to scale, but it is 0.011. So it's less than 0.05, further away from the null hypothesis, so we would reject. If our p-value was bigger than 0.05, let's say it was 0.06, then that would be closer to the null, and we would not reject. Okay, hope that makes sense. So here we reject the null hypothesis because there is sufficient evidence to conclude, and our conclusion is toward our alternative hypothesis, which is P1 is greater than P2. So it would be that one, and let's check it. All right, well, I hope that makes sense, and thanks so much for watching, and let me know if you have any further questions. Thanks. Bye. Hi Jada, this is Christine, and I thought it would be easier to do a video to explain this to you. It looked like it was in part C where you had your question, and really the easiest way to do this is in StatCrunch. So I wanted to take a look at it doing in StatCrunch with you, and then I can also show you how to get the input, the z-score that you need to, also how to get that. So let's go ahead and we can take a look at a similar example and go down to part C. So here we're asked to determine and interpret 95% confidence interval for the mean amount of time people aged 15 or older spend eating and drinking each day. And we have the sample standard deviation as 0.76, and we're determining a 95% confidence interval, and we also have the sample size up here, the mean. So we can go ahead and go right into StatCrunch, and because this is a confidence interval for means, we're going to use, we're going to go into stat and then into the t-stat, since it's for means, and t-statistics. And then we're going to select, let me scoot this over so you can see it better. We have summary data. So here we've got the mean, which is 2.09 hours, and then the sample standard deviation is 0.76 in the problem, and then the sample size, 1,124 people are sampled. And then hypothesis testing will be in the next module. Here we want the confidence interval from you. We can change this if it has 90 or a different percent, then we can change that. But that looks good to go for now. And then here we have our lower and upper limit for our confidence intervals. So let me go ahead and screenshot it, and then we'll make sure that this is correct. So here's the lower bound, 2.05. Okay, I don't even need to pull up my screenshot, it's right there, and when we round 2.05, and then 2.13 for the upper bound. So that looks right on track. Now, to answer your question, so you can easily do it that way, the easy way, or you can use their t-table, or go in here and get the, calculate the p-score. So here, for this is degrees of freedom, we look at the amount of people, and I don't, well, anyway, it was 1124, and we subtract 1, so that'd be 1123. And then one thing I need to explain here is that, so here it shows the degrees of freedom, 1123, and that's just you subtract 1 from the sample size. And then the other thing that I wanted to sort of explain a little bit, so on 95% confidence interval, we can think of the bell-shaped, sort of the approximately normal distribution curve, and 95% of the data is in here. So here what we're trying to, and 100% of the data is under the the curve with all of the data, and we could subtract this out, and then we'd see 5% is left over. So 5% covers both of the tails. So one tail would be 2.5%, and so would the other, because we're just dividing 5% in half. And so we want to find out how many standard deviations from the mean, the number of standard errors, we could call it, from the mean is, the sample mean is from the population mean. So when we look at the table or in StatCrunch, we can get this value, and we'll get the negative value, but it'll be the same value on for both the upper and lower. So let's go in here, and we're going to be looking up, instead of 2.5%, because we look up the amount in the tail, it's going to be 0.025, because we're converting it to decimal. So now we have everything we need, and we put in 1123 for the degrees of freedom, and for the area under the tail, put that in, and then we got negative 1.96, and we're going to and then over here it would be positive 1.96. So, and in the formula that you use, you're going to be adding it after you multiply it, you're going to either add it or subtract it. So hope that makes sense, and really doing it from StatCrunch in the beginning, I think, is the way to go. And you'll have access to StatCrunch in your on your exam and everything like that. And you are doing an awesome job in this class, so love having you as my student, and please keep chipping away at it and doing a great job. So hope this helps. Bye.